All right, students, welcome to our first attempt at guided notes through video. So it's a reminder, take this opportunity to pause the video and either print the guided notes from Google Classroom if you have the option, or at least make sure to pause and set up your guided notes like how I normally would print them off for you, so you'll have your notes. As we move on, you'll see that there are problems numbered. So those blank copies are available on Infinite Campus. And make sure that you've got in your notes, we've got our objective, and then the homework from the book. The only difference here is we are not doing the presentation problems. So if you need it, or if it's helpful for you, if you look down here, you should have the option for closed captions, which will hopefully help you if you need subtitles or you think it would just help. So let's get started. Our first notes that we're talking about today are coming back to the idea of proportional relationships, but now that we've done more with graphs, we're going to tie that into our knowledge as well. So as a reminder, how do we tell if something is proportional? Well, up until now, we've always talked about it like a fraction. Another way to think about it is that there is a constant rate of increase or decrease. Now, when you see a word problem and you're talking about rate of something, that means you're generally going to be talking about the slope of the line. And so you can remember slope is rise over run like this, and constant, and this is how we'd write it as a math problem, constant is equal to k, where k here is just a number, meaning constant, it's not a variable, which means like it could be 7, it could be 2/3, anything like that. So slope, again, y over x, this is how we're used to seeing it. The other thing is that if one unit equals 0, so does the other. So if both x and y are 0, that means in terms of the graph, it passes through the origin. So that means if we're looking at the graph over here, all proportional relationships graphs are going to pass through this point right there. Now, remember, you can pause this video at any time if I'm going too fast and leave any questions in the comments below. Now, since if we're looking at our idea here, the constant is equal y over x equals k. If we multiply both sides, by x, you can also write proportional relationships as y equals kx, which looks like our slope-intercept form, where it goes through at 0, so you could have a lot of different examples. You know, this would be a positive proportional relationship. Here we could have a negative proportional relationship. These are all just different examples. So now we're looking at problem number 1 and using this knowledge. Write the function of the direct variation or proportional relationship. Your book will use the vocabulary direct variation, but the Minnesota State Standards use the word proportional. They are synonyms, they mean the same thing. If y equals 1/2 when x equals 8. So, writing the function, we can use either of the two forms here. I'm going to use the fraction form. So if we know that y over x equals k, when we write a function, we know that we can leave our y and our x terms as they are. Those don't need to be replaced, but that means that k has to turn into some number. So in order to find that, we're going to use substitution. So since we know y here is 1/2, then we can say, oh, well, 1/2 over x, which is 8, is equal to k. And then by evaluating that, we end up with 1/2 divided by 8 equals k. and so then k is 1/16. And so the equation for our relationship would be y over x equals 1/16, which looks like a nice familiar proportional relationship. Here we have a little bit more complex word problem for number 2. Use the table below to answer the following questions. Comparison, price and weight of apples. We've got pounds and cost. So the first thing we want to recognize is that though this looks very different than our last equation, we're still looking at two variables, a changing variable of the amount of pounds that you buy and the changing cost. So you want to assign that an x and a y, and when we look at tables like this, generally the first one is the x and the second is the y. And when it comes next to writing the function, if you remember in the last example here, they gave us a point where we had an x and a y value. Here we can just pick any one. I'm just going to pick the first one. It wouldn't really matter. But what this says then is that x is equal to 3 and y is equal to 4.5. So if we plug that in to our equation, we get 4.5 over 3 equals k. I'm going to move that decimal point over, add the 0. 45 over 30 simplifies by 15, and we end up with 3 over 2. So then our final equation, y over x equals 3 over 2. All right. For parts B and C, it's going to be helpful if we just keep our equation from part A written over here, because we're going to use that several times, remembering that y is our cost and x is our pounds of apples. So in part B, where it asks how much would 9 pounds cost, we know that this is an x value, and then the question is asking what is our y amount. So we can just plug it into the formula we have. Y over 9, since we're replacing with that x value, is equal to 3 over 2. Solve for y, so I multiply both sides by 9, or you could cross multiply. Both would work. But since 9 is in the denominator, this just seems more straightforward. 27 over 2. But because we're talking about cost, this doesn't really make sense as a money amount. So instead of a fraction like we might use, we'll turn it into a decimal, which would be 13.5, since it's dollars 50. All right, for our last one, you can see that it's saying how much could we buy for $5? Well, that's a y value then. And so then our goal is to find x, how many pounds. And so here we know our y is 5 over x equals 3 over 2, which is our k value from part A. And here we do want to cross multiply because we have our variable in the denominator. So when we cross multiply, 5 times 2, 10 is equal to 3x. Divide both sides by 3. And we end up with 10/3 pounds. And while you absolutely can answer this as a fraction, it's a little awkward. So 3 1/3 pound, or 3.3 repeating pounds. But do remember in your word problems to include your units. All right, thanks for sticking with me during this first set of example notes. Be sure to leave any questions in the comments below. And if you see a question from a classmate that you know the answer, absolutely feel free to jump in there. Not sure how to end this. Smash that like and subscribe button, but do be sure to remember to complete your daily check-in and look for any questions on this topic tomorrow. Nominate any homework questions that you might have, and I'll get back to you within 24 hours. All right, bye.